that we have about 5 other people who are working on research projects, and those may not be construction-based, they may be long-term, kind of, let's say 3 years to 5 years, and they're more kind of geared toward laboratory research or production of scientific articles. And then what I focus on is this WOOD program. So WOOD program is what you saw presented partly in the exhibition in Seoul. WOOD program began 20 years ago, and it was initially just a Finnish language course, and it was for students in the master's program. So students who were already finishing their master's, completing their master's degrees, would take this studio where they would design and build buildings. In 2000, so now 14 years ago, it was decided that this study in wood technology was a good way of bringing international people to Finland and bringing more international students to the university. So they decided to change it from just one studio to a whole set of courses. So we have every year about somewhere between 12 and 18 students, usually we try to make it around 15, that come to Finland and take full 60 credit courses, so this is like a full-time course load. They take lecture courses, which are taught in the Department of Architecture. They take lecture and laboratory courses in the Department of Forest Products Technologies, so wood sciences. They take design studios, which are taught here in the Department of Architecture, lecture courses in history, and then of course excursions to visit sites related to wood construction. And in each of the 2 terms they get 30 credits, and the bulk of what we do, so the building project is this WOOD program special project, so that's the kind of core of the program. Basically we bring them all here. They come from, I think over in the last 15 years we've had students from 41 countries. We've had a few Koreans, not so many, but I would say maybe 4 or 5 Koreans. One of our students last year was one of the best students we've had. I don't know what he's from Incheon, and he was a really, really good student. Min Woo Seo. Really, one of the best I've ever taught. But we bring everyone here, and in September, and in the first day of the year, we drive about 3 hours to central Finland. We visit a pine forest there. We take the students out into the forest, they have a lecture, and they talk about the growth of wood. And then we find the nicest pine in the whole forest, and then we cut it down. And then we start sawing it into logs, and talking about the quality of the timber that is produced, what's particular to that place, how it's grown. This is a professor of forestry, so it's a little bit about how the forest is managed, but mostly about the quality of the wood. We do this all in one day, it's quite a long day. And of course that leads to a discussion about how the wood shrinks its wells and how you produce different materials from it. And of course we also take a look at how that gets bigger. We go to some of the big sawmills. And then we begin with the projects. You saw these probably, remember these from Seoul. This is the first task for the course each year, so each student it's always been the same task. It's 20 centimeters cubed, and each student is asked to, we give them raw material, pretty much we give them boards which look like this size, and they have to turn it into this study of wood. Then we do a series of smaller tasks. So this is the kind of design studio. They do the first task by themselves. Second task they do in groups of 3, and they have to design the joint. And we take it to the engineering lab with our civil engineers. We talk about the quality of the joint, the decisions that they made, and we break them. Then we move up scale and we construct these frames, which I can show you. After they build the frame, they have to make a covering for the frame. They have about 2 weeks for this exercise in the workshop. And so while they're learning kind of design skills, and all of them have already studied some architecture, so they're trained as designers, but they're also learning how to use the workshop because it's important that they begin to learn something about it. They will build the main project in the spring, and they have to get some training in the workshop. While we're doing the smaller studies, then we also are working on the main project. So we choose one project, or we give the task in October, and each student begins developing their own design in a kind of normal studio. So they make a series of models and drawings, and then the final review in December, we choose one project to develop. So the project that you just saw, the model, was the student's proposal that we chose this year. Well, the one behind you is another proposal, the same, this one, another one. So we have a final review with everyone's idea for what we should construct, and we choose one. Becca and I make the decision. The students have some influence, but mostly it's us. And then as soon as we choose the project, we do what's beginning now. Everyone starts studying every aspect of it. How do the joints go together? What kind of material are we going to use? How are we going to bend it? How do we do the foundations? How do we transport it to the site? How much time do we need for each of these things? And we ask the students to the whole spring term. They study all of the solutions in drawings and models. They use the workshop downstairs. And above all, we ask them to produce a lot of models. We always require that they do a lot of, it's a lot of work, but it's particularly a physical work. So it's not, we want to kind of not only be based around drawing, but particularly heavy on model construction. We ask them to come up with ways to test their ideas. So we ask them to invent ways. This is a girl standing on the frozen sea, testing the scale of different, I think this is testing different size circles for the planet. And of course, once we have solutions for all of the connections, then we also go back to the civil engineering lab. I'm pointing that way because it's in another building, and we do tests on all the joints to see if they will be rigid or not. We evaluate them for all of their characteristics, so visual suitability, or visual characteristics, suitability, tension, compression, shear strength, humidity and moisture movement, and constructability, and lastly, whether or not it's a wood joint, whether or not it's really something that we think wants to be done. The students have to make a plan for the stages of the construction and the production of all the elements, because they will make everything themselves. So they produce drawings very often like this, which kind of show how everything gets assembled. And then they begin fabricating the elements here in the workshop. So they construct most of the things that we manufacture are built right here in the building, and then we do the assembly work in our backyard and transport it to the site. It depends on the site how we work. So this is taking those elements and putting them together in the backyard. We sometimes work using analog technique, no digital. We don't have any big CNC cutters here in the workshop, but we sometimes find it necessary to use the CNC cutter. So we usually, when we do digital fabrication, we work with one of our partners. So we have a construction company that we will call them and say that can we have 1 day or 2 days on your machine. We take our material there, we work with them to prepare the files, and then we do all the cutting, and then we bring it back here and do the assembly work. So again, this is a different house going up in our yard. That's sometimes the elements are small that we can lift ourselves. Sometimes they're a little bit larger in scale and you can haul in and get a truck. The students are responsible for all the planning of this. So if there's going to be elements that need to be lifted with a crane, then they need to figure out where to get a crane, call them, make sure that, so it's a kind of really a simulation of a real building project in an office. It's a lot of work. This is pretty much what the students look like at the end of the year. But they have fun along the way. I don't know what they're doing. And of course, we have very good facilities, which is, I think, one of the main things of the program. I don't know if we do any, even if we're not good teachers, if you give the good students good facilities, they produce amazing. I will show you these workshops downstairs. As I say, the way that we work is, we're a bit like an office in the sense that I don't think of myself, and I don't think Becca and I think of ourselves as teachers as much as we think ourselves like the leaders of an office. So the students in this sense are a bit like our employees. They come to us, they present the solutions, they tell us what needs to be studied more, what they've already solved, and then we sort of agree or disagree. We say, no, I think you can do it better, or yes, I think this is solved now, and go forward to the next thing. So we work constantly by them presenting to us through models and through mock-ups. kind of theme of the program is learning by doing. This is what I think in Seoul, this was kind of one of the themes of Nordic education. The reality is it's learning by mistake. We make mistakes. The students make mistakes. Of course, we have to keep it in a reasonable range. We don't want them to hurt themselves. We don't want to produce projects that are mistakes. But we understand that that's exactly how decisions have to be made. You have to test things. You have to reach a point of failure before you understand it. And I would say that all of our projects, although we do a lot of different kinds of projects, the theme with each project is experimentation. We don't just want to train people in how to build a normal house. We're not that interested in truth. Of course, I have a lot of respect for people who are doing traditional techniques or kind of learn master carpenters, for instance, who study a kind of craft. What we do is very different. We're always experimenting and testing new methods of fabrication and new forms of construction. And as I say, learning from mistake, this is something that happens very often. You make the best plans and then you get to the site and you realize that something doesn't fit, and out comes the sledgehammer and you start making it work. But hopefully our projects that we realize don't look like mistakes. They shouldn't be visible. So the quality of the projects we maintain. Something that's quite distinctive is, although we're experimental, I think the quality of the projects that we build is very high amongst design build studios. These are just a few projects. Of course, our biggest project done yet was the World Design Capital Pavilion. This was built in Helsinki 2 years ago. I finally managed to get our website working a bit better, and I'm adding the projects, so now not all of the projects are there. In 20 years we have built 31 projects, so I have maybe, but that's not the only, I would say the design build studio is the kind of core of what we do, but the important thing, I think a lot of this design build work is happening, learning by doing kind of studios are happening in a lot of places. In Germany, for instance, in Stuttgart, there's a very good studio. But the thing I think which is kind of most unique about our approach is that it's not just one studio, it's actually all of these courses. So the students have, on Mondays and Wednesdays, they have lecture courses looking at kind of in the laboratory, looking through the microscope at the cellular construction of different species of wood and having a real kind of high level of expertise on microscopic kind of understanding or cellular understanding of the material, all the way to industrial processes and how is plywood made, how is sawn timber, and how is glulam made. And the work of the studio is supported by all of the lecture courses. I don't think we couldn't just gather a group of students here and go. We have done summer schools where we just gather a group of students and say we're going to build a project, but really it requires all of these kind of higher level studies in the qualities of wood itself as a material and the history of wood construction. So I think that's probably what's most unique about us as compared with many other design build studios. The construction project begins, we choose the project that we will develop in December. So we start the design work in January on the main project, and we try to order the material by first days of April, and then we have about 6 weeks for the construction, maybe 2 months. So if we order the material by the 1st of April, let's say by the Easter holiday, then we will have it by the middle of April, and we have about 1 month. It depends on the project. Some projects have a lot of fabrication, like in the workshop. Some projects have more site work, but I would say that the actual construction time is about 1 month to 6 weeks. In Finland, we might have snow until end of April. Like by May 1st, the snow is melted usually, but we can easily have snow for April. So we try to do the construction work inside for the month of April, and then once it starts to get warm, it's also nice that once it starts to get nice and sunny and the snow is melted, then we move outside. That's kind of one of the biggest factors that's pushing it forward at a political level, but for me there's other advantages architecturally to it, which have nothing to do with environmental efficiency. I think that wood building systems are very flexible. They're very easily adaptable. When you're working with steel and concrete, the levels of prefabrication are quite high, and the tolerance
can easily, for all the reasons that are obvious, if you get wood elements, you can modify them on site relatively easily, even when they're very large. So that yields some advantages in terms of the constructability. And then, of course, it has other advantages in terms of some of the things that we're studying now, like the quality of interior environments. We're discovering now that a lot of buildings that we built in the 70s and 80s have really poor interior environments because there may be concrete with some kind of oil-based, like polystyrene insulation, and they're trapping moisture in the wall cavities. We have many, throughout the world, but especially in cold climates like Finland, we have many renovation projects now where we're trying to get rid of interior mold and retrofit buildings which have interior air quality problems because they're using such unnatural materials that can create long-term problems. The good thing about using wood and wood-based materials is that if you use them carefully and they're correctly detailed, the building can last for hundreds of years. We have wood buildings that are more than 100 years old, and there's no reason that a quality wood building can't last 100 years. Then, of course, there's other things that, like some of the interior projects, research projects that we have now, for instance, we're testing whether or not it's possible. If you think about the energy consumption of a building, we're always heating, especially in a country like Finland where we're heating our buildings all the time. Or in Korea, you have heated floors in Korea. So heating floors, of course, the reason you do it is because it makes you feel warmer. It actually makes the air temperature. You don't have to bring the whole temperature of the room up to feel warm if your feet are warm. So the same thing is true in a wood interior. If you walk on wooden floors, the temperature of the room can actually be a bit lower because the thermal transfer from your body to the building is lower. So if we could say, for instance, lower interior air temperatures 1 or 2 degrees, it means that we don't have to heat buildings as much we don't have to put as much energy into buildings in order to get the same interior level of comfort. And that's something that can be enabled by wood. So if I sit on a wood chair, my body doesn't get heat to it as readily as if I sit on a concrete bench or something. So I think that's also one of these things, advantage that's quite specific. But then one of the biggest tools is the recyclability. It's back to kind of environmental questions. With wood, we have viable options. If you ever watch a concrete building come down, being disassembled, there is almost nothing to be done with concrete. Of course, you can crush it, you might turn it into something, but mostly you're getting a lot of waste. And of course, nowadays, the same thing happens with plenty of wood buildings, but in principle, there's no reason that we can't recycle wood buildings. When you take down, it's amazing now that when you see a wooden building being taken down after 40 years, most of the elements, the structural elements, are still perfectly good quality. If you remove the nails from them, you remove the fasteners, maybe plane them or solder them into smaller dimensions. They have in them. The fact is we have a lot of wood, and there's a strong interest by the Finnish government and Finnish industry to sell wood to people abroad, but also use it here in Finland. So in that sense, we get a lot of attention because there are plenty of people who make wood and sell it. But I would say also that this question of the the next half century is going to be, I think for the next 50 years, we're going to be talking all the time about environmental efficiency and energy efficiency. And because when you begin to look carefully at the amount of energy embodied in any wood construction, it's so much less than any of its competing materials that there's no question that wood starts to become. Because if you think about the energy required to get steel to get the ore, to mine it, take it out of the earth, form it, or even to recycle it, and the amount of heat required, the amount of energy it takes to form a steel beam is so much more than the amount of energy it takes to produce, say, a delaminated beam with comparable characteristics. As we begin to become more aware of how much energy goes into the things we produce, and you have to start saying that, okay, my building consumes this much energy or produces this much carbon, then in all of those equations.
It's usually glue laminated production. So there are a couple of big manufacturers. For Kamppi Chapel, there's one major manufacturer in Turku, who has done those elements. I think I have the images of the chapel, but they're basically big beams, which are like gymnasium beams, which are glued together. They're thin boards, which are then laid on top of one another and glued. The company which has done a few projects in historical. The company is historical. They have also built this Sonata chapel. That will kind of name like one. But that's how this particular. You can see that it's straight boards, which are then glued together in the factory to the shape, and then wrapped around. That's the model. I believe this is the model that is. These guys, the Cocox S guys, are professors here now.
Oh, really?
Yeah.
In architecture department?
Yeah. Yeah. So this is, and here it was, they actually had a tent around the structure for quite much of the time. So this is the elements were pre-cut in Turku and then brought to the site and put up with a large crane on site. And then the interior walls are like this. So the interior walls are actually not bent, they're just straight pieces which are cut to a curvature and then sanded smooth. And then the exterior wall is actually bent. The exterior wall, the bent elements,
Yeah.
these are the glue laminate elements in the center in this section. And then there's an a layer of insulation. And then there's this exterior cladding. Oops, sorry. There's this, which is the detail for the exterior cladding, and it's three pieces which are glued together and then screwed to the frame with the screw. And the interior layer is just one piece and it's cut and sanded. But there's an air cavity. This is all insulation.